is Lars Bjorndal. I am originally from Norway, but I'm currently pursuing a bachelor's degree in electrical engineering here at the University of Florida. During this summer, I participated in Dr. Wilkie's BioEnergy and Sustainability Internship program. During the internship, I participated in seminars, went on field trips, assisted in research on algae, and worked on individual projects. I have a great personal interest in sustainability, and I hope to work with the development and implementation of sustainable ways of producing energy. This internship has thus been very rewarding for me, as it has taught me a lot about sustainable practices and how they're implemented today. For one of our field trips, we visited a small farm in Alachua. The farm had a large biodigester which used organic waste as feedstock to produce methane gas. This gave the farm both a sustainable and efficient way of dealing with their organic waste and gave them biogas which they could use to cook their food and pasteurize their milk. It was very inspiring to see how the biodigester system was implemented at the farm and seeing how something that has been developed inside the lab can actually be used outside. For one of our other field trips, we visited the landfill in Archer. The landfill has been closed since 1998, but still requires monitoring due to the leachate. This was a very eye-opening experience, as it showed me more efficiently than I believe I could ever learn in a classroom the sheer impact of our waste. And it also made me realize that there is no globally established best way of treating waste. Because I know back in Norway, most of the waste that would have gone to landfills here, we use to burn and generate heat. Our research project consisted in investigating algae as a tool for carbon capture and reutilization as a way to reduce the emissions of the OUC coal power plant. For our project, we fed different cultures of algae with CO2 and measured their growth and productivity on a weekly basis in order to determine which culture would be best suited for capturing carbon and reducing emissions. The individual project has been one of my favorite parts of the internship program. It has allowed me to individually select a problem that I wish to solve and then work out my own way of how to most efficiently solve this problem and then going through with a procedure for that. For my first project, I decided to tackle the issue that a lot of smaller farms face here in Florida with irrigation and a dependency on fuel-based pumps. And because this sort of pumps, they're very clunky and could be difficult to move around. They also pose a risk in terms of fuel spills, which can contaminate the ground. And because they run on gas, they obviously produce CO2 emissions. So what I did is I designed a portable solar-powered pump. So this is a solar panel that is connected to a car battery that is continuously charged as this is out in the sun. And that is again connected to a DC powered pump, which has a switch for when to turn off and on. And this unit could be connected to any water supply that would be around with this tube, and then connected into either a hose to move the water to another place or directly into a irrigation system, as we have done here at the lab. So the key aspect of this setup is that it's designed to be so mobile, so you could easily move it between different points where you wish to use the pump. Or you could use it to pump water up to an elevated tank for either drip irrigation or just to give the water gravitational potential energy or storage. My second individual project was a continuation of research I'd previously done on the preparation of sanitary meals and sterilization of water through solar cooking and heat. For this summer, I decided to prototype and start the construction of a solar cooker or solar oven, which I would use to carry out my further experiments. So what you can see here is my first very rapid prototyping of getting the dimensions of the solar oven. After that, I moved on to the process of selecting what sort of material I should use for constructing the cooker. And I settled with metal because it's an easily recyclable and also salvageable material, and in addition to being very durable. So I'd be able to construct something that could last. Now I'm currently at the state of construction, and that's something I will continue with after the summer, when I will finish the construction of the prototype and start with the improvements that I will inevitably have to do in order to make it a finished product. Now, moving towards the end of my internship, the experiential learning that this program has facilitated through individual projects, research, field trips, and discussions with Dr. Wilkie has been incredibly rewarding. I've gained a lot of unique and valuable insights in the world of sustainability. I have also learned how to much better formulate a scientific thesis, conduct scientific research, or do a scholarly literature review, and properly citing documents, as well as having gained very valuable and unique insights in the world of sustainability, and how this connects to things such as humanitarian efforts. Overall, I would warmly recommend this internship to anyone who's even remotely interested in sustainability or bioenergy.